In the words of George Cantor, the art of proposition of a question must be held of higher value than solving it. Here, there is a minar. Can you find height of this minar without actually measuring it? And there is a palm tree. Palm tree. Can you find height of this palm tree without actually measuring? And there is a lighthouse. And there is a ship. By observing from the top of the lighthouse without actually measuring, can you find distance of the ship from the bank of the sea? In all the situations mentioned here, we can find heights or distances by using some mathematical techniques which comes under branch of mathematics, trigonometry. The word trigonometry is derived from three Greek words. The word trigonometry is derived from three Greek words. Those are tri, gonia, and metro. Trigonometry is derived from three Greek words, tri, gonia, and metron. Here, tri means three, gonia means angle, metron means measure. So here trigonometry is nothing but three angle measure. We can see is three angle measure in triangles. So trigonometry is the study of relationships between sides and angles of a triangle. Trigonometry is the study of relationships between sides and angles of triangles. Early astronomers used trigonometry to find distances of the planets and stars from the earth. Now let us observe three right angle triangles with proportionate sides. Here I am taking a right angle triangle ABC with lengths of sides 3 units, 4 units and 5 units. Right angle is at B. Another right angle triangle PQR. Right angle is at Q. lengths of sides 6 units and 8 units 10 units. And some other right angle triangle, the lengths of sides that is 15 units, 20 units and 25 units, right angle Y. In these three right angle triangles, now I am going to take ratios of the corresponding sides. Here AB by BC, PQ by QR, XY by YZ. Here AB by BC, PQ by QR, XY by YZ. AB by BC, that is 3 units by 4 units, that is 3 by 4. PQ by QR, 6 units by 8 units. 2 3s are 6, 2 4s are 8, so its value is 3 by 4. Simplified. XY by YZ, 15 by units by 20 units, that is 15 by 20. 3 5s are 15, 4 5s are 20, its value is 3 by 4. 3 by 4, 3 by 4, 3 by 4. From this we can observe AB by BC equal to PQ by QR equal to XY by YZ. AB by BC equal to PQ by QR equal to XY by YZ. AB by BC equal to PQ by QR equal to XY by YZ. On the other hand, I am taking these two sides. BC by CA, QR by RP, YZ by ZX. Here BC by CA, that is 4 units by 5 units, that is 4 by 5. QR by RP, that is 8 units by 10 units, 8 by 10. 2 4s are 8, 2 5s are 10, so its value is 4 by 5. YZ by ZX, that is 20 units by 25 units, 20 by 25. 4 5s are 20, 5 5s are 25, 4 by 5. 4 by 5, 4 by 5, 4 by 5. This ratio is constant here. So BC by CA, that equal to QR by RP, that equal to YZ by ZX. So BC by CA equal to QR by RP equal to YZ by ZX. On the other hand, we can take, if you take CA by AB, RP by PQ, ZX by XY, that also constant. So here corresponding sides are in the same ratio. These two sides ratio 3 by 4, 3 by 4, 3 by 4. These two sides ratio also 4 by 5, 4 by 5, 4 by 5, constant. From this we can say that corresponding sides are in the same ratio, so that these triangles are similar triangles. These three right angle triangles are similar triangles. Corresponding sides are in the same ratio. So these three right angle triangles are similar. We know in similar triangles corresponding angles are equal. We can write angle A equal to angle P equal to angle X. Therefore, angle A equal to angle P is equal to angle X. Let me take this measure of angle as theta. So angle A is theta, angle P is theta, angle X is theta. For this particular angle theta, corresponding sides are in the same ratio in these right angle triangles. If there is a change in theta, then this ratio value will change. This ratio value also will change. For this particular angle theta, corresponding sides are in the same ratio. Corresponding sides are in the same ratio. If there is a change in theta, then this ratio value get 3 by 4 get changed, then 4 by 5 get changed. So there is a relation between angles and sides in these triangles. This relation we can establish in trigonometry. Now it is clear that ratio of two sides included to particular angle does not vary with the lengths of the sides in those right angle triangles if that angle remains same. So these ratios we can observe in trigonometry, this relation between angles and sides. I am taking one right angle triangle ABC, right angle B. Let me take measure of angle A as theta. Ratios of the lengths of sides with respect to acute angles in the right triangle are called trigonometric ratios. Now we are going to know trigonometric ratios. There are 6 trigonometric ratios. Before going to know trigonometric ratios, let us name the sides of the right angle triangle. Right angle opposite side always called as hypotenuse. AC is hypotenuse. Theta opposite side is called opposite side to theta. So BC is called opposite side to theta, and theta adjacent side is named as adjacent side to theta. Adjacent side to theta. So now let us know the trigonometric ratios. Ratio of opposite side to theta and hypotenuse is constant with respect to that particular angle theta in all the similar triangles. So opposite side to theta by hypotenuse is a constant. Opposite side to theta by hypotenuse. This ratio is constant with respect to that particular acute angle theta. This ratio is called as a sin theta. Sin theta. Sin in short you can write as sin. We read as sin theta. Opposite side to theta by hypotenuse. This ratio is named as sin theta. There is no meaning to sin without theta. Next, adjacent side to theta by hypotenuse. These two sides ratio also constant. So adjacent side to theta by hypotenuse. This ratio is named as cosine theta. In short, we write it as cos. COS. We read as cos. Cos theta. Adjacent side to theta by hypotenuse is named as cos theta. Opposite side to theta by hypotenuse named as sin theta. Adjacent side to theta by hypotenuse is named as cos theta. And opposite side to theta by adjacent side to theta. This ratio also constant with respect to particular angle theta. Opposite side to theta by adjacent side to theta. This ratio is named as tangent theta. Tangent in short we write as TAN, tan. We read it as tan theta. Tan theta equal to opposite side to theta by adjacent side to theta. On the other hand, not only these three ratios, opposite side to theta by hypotenuse is named as sin theta and its reciprocal, hypotenuse by opposite side to theta. That ratio also constant. So, if you take its reciprocal, hypotenuse by opposite side to theta. This ratio is called as cosecant theta. Cosecant theta. In short, we write as COSCC, cosec theta, cosecant theta. And adjacent side to theta by hypotenuse. Adjacent side to theta by hypotenuse we named as cos theta. On the other hand, its reciprocal, hypotenuse by adjacent side to theta, it is also constant. Hypotenuse by adjacent side to theta. Hypotenuse by adjacent side to theta. It is also constant here. We named it as secant theta. Secant theta. Secant in short we write as CC. Secant theta. Finally, opposite side to theta by adjacent side to theta, we named it as tan theta. Its reciprocal, adjacent side to theta by opposite side to theta, that is also constant. So, adjacent side to theta by opposite side to theta. Adjacent side to theta by opposite side to theta. It is also constant. We named it as a cotangent. In short, we write it as COT, cot theta. Sin theta is opposite side to theta by hypotenuse. Cos theta is adjacent side to theta by hypotenuse. Tan theta is opposite side to theta by adjacent side to theta. Cosecant theta is hypotenuse by opposite side to theta. Secant theta is hypotenuse by adjacent side to theta. Cot theta is adjacent side to theta by opposite side to theta. Okay, sin theta. Sin theta I will write as opposite side to theta by hypotenuse, so that BC by AC. BC by AC in this right triangle. Cos theta. Cos theta is adjacent side to theta by hypotenuse, so that AB by AC. Next, tan theta. Tan theta is opposite side to theta by adjacent side to theta, so BC by AB. BC by AB. Next, cosecant theta. Cosecant theta is hypotenuse by opposite side to theta. So that cosecant theta is cosecant theta we can write as hypotenuse by opposite side to theta, that is AC by BC. That is AC by BC. Next, secant theta. Secant theta is hypotenuse by adjacent side to theta, so that AC by AB. Next, cot theta is adjacent side to theta by opposite side to theta. Cot theta is adjacent side to theta is AB, opposite side to theta is BC. AB by BC. Cot theta is AB by BC. These are the 6 trigonometric ratios of a right angle triangle in trigonometry. Let us define sin theta. Ratio of the opposite side length of the ratio of the length of the opposite side of an angle and length of the hypotenuse is called sine of that acute angle in that particular right angle triangle. Cos theta, ratio of the length of the adjacent side of that particular angle and hypotenuse is called cosine of that acute angle in that right angle triangle. Tan theta, length of the opposite side of that acute angle and length of the adjacent side of that acute angle, that ratio is called tangent of that acute angle in that right angle triangle. Cosecant theta, ratio of the length of hypotenuse and length of opposite side of that acute angle is called cosecant of that acute angle in that right angle triangle. Secant theta, ratio of the hypotenuse of the right angle triangle and length of adjacent side of that acute angle is called secant of that acute angle in the right angle triangle. Ratio of the length of the adjacent side of the acute angle and length of the opposite side to that acute angle, that ratio is called cotangent of that acute angle in that right angle triangle. These are the 6 trigonometric ratios. It is very clear. Sin theta reciprocal is cosecant theta. Sin theta is BC by AC, cosecant theta is AC by BC. Cos theta reciprocal is secant theta. Cos theta is AB by AC, secant theta is AC by AB. Tan theta reciprocal is cot theta. Tan theta is BC by AB and cot theta is AB by BC.